video is going to be on how to transform rectangular coordinates into polar coordinates. Recall that a point can be written in Cartesian coordinates or rectangular coordinates as x and y, so a horizontal component and a vertical component, or polar coordinates r and theta, or a distant a direction component and a distance component. So you have theta and distance. So if you looking at this representation, we can see that r is just going to be x squared plus y squared, because this is a right triangle. We just use Pythagorean's theorem to find r. Theta gets a bit trickier, but you can see that theta is going to, the tangent of theta is going to be y over x. So we're going to use that to find our reference angle. So I'm just going to go through a few examples to show how this works. So here is the point -5, 8. R, you just use the Pythagorean's theorem to find the square root of 89. You just take 5 squared, 8 squared, add them together, square root it. We can find the reference angle for theta by taking the inverse tangent of y over x. So -5 is our 8 is our y, -5 is our x, so we take the inverse tangent of 8 over 5. That gives us a reference angle of 57 degrees. We can notice that the point -5, 8 is going to be up here somewhere. And so our theta, this theta is going to be 57. We want to find this angle, so that would be 180 minus 57. Right, because our reference angle is 57, so that's the angle. So that's the angle over here is 57. We want the angle from the positive x-axis. To get that, we do 180 minus this angle, and that gives us 122.01. And so that makes our point, our r value, which was the square root of 89, and our theta, which is 122.01. Here is another example where we have the point -square root of 2 and -square root of 2. Our r is just going to be the x squared plus y squared, square root of 2 squared plus square root of 2 squared. We get 2 plus 2 is 4, square root of 4 is 2, so our r is 2. This we take y over x, so square root of 2 over the square root of 2. That gives us 1. The inverse tangent of 1 is 45. So our reference angle is 45. We look at what quadrant this is in, and it is in the 4th quadrant, right down here. Our reference angle is 45. So the theta we want to have, this theta, is going to be 180 plus 45. 180 plus 45. That gives us 225. So we have our r and we have our theta, our r and our theta. So that gives us our point. So our point would be 2 and 225 degrees. This is the last point I'm going to go through. It is the point 0, -7. So we can just use the formula to find our r. We have x squared plus y squared, 0 squared plus 7 squared, 49 7. So that makes sense because this point corresponds to this point down here, and so the magnitude of that, the magnitude of this is just going to be 7, right? So we have to find our theta now, and our theta is y over x, so we have 7 over 0. This formula doesn't seem to work for this situation, so we're just going to have to visualize what this point looks like. Again, this is our x and y axis. This is our point. If you notice, you can see that this is going to be 7, right? We already calculated that from the formula. But our angle is going to be 270 degrees. Because that's what straight down is, right? Because this is 90, 180, 270, 360. So that makes our point. So this one you don't use the formula for it, you just sort of use geometry for it. And that makes our point, in polar coordinates, 7, 270 degrees. I hope this is helpful with trying to convert rectangular coordinates into polar coordinates. If you need any more help, you can go to the SVSU Canvas page for this course and post in the discussion or on the chat, or you can go to the SVSU Discord where there's tutors on there during all tutoring hours ready for any questions you might have.